Z11EN Coursework to Reset. Part A. Semiconductors are usually poor conductors. A method called doping is used. Doping is where conductivity of the material is increased by controlled addition of impurities to the intrinsic semiconductive material. There are two categories of impurities, N-type and P-type. To make intrinsic semiconductive material more negatively charged, or N-type, the element antinomide is used because it has excess donor electron, making the material negatively charged. To make the intrinsic semiconductive material more positively charged, it will be doped with P-type impurity. Usually boron element is used. Boron atoms lack a spare electron, therefore it has a hole and is positively charged. When a single piece of silicon is doped with P-type impurity at one end and N-type at the other end, a P-N junction is formed where the two oppositely charged sides meet. Around that junction, a depletion layer is formed. What that means that at the instant of P-N junction formation, the free electrons in the negative region or N region near the junction begins to diffuse across the junction into the positive region or P region, where they combine with the holes in the positive region. This causes the negative region to lose free electrons, creating a layer of positive charges near the junction in the N region. The positive region loses holes when the free electrons combine with them, creating a layer of negative charges near the junction in the P region. These two layers form the depletion region. In the depletion region, an electric field is formed as a result of opposite charges in the P-N junction. The electric field prevents the free electrons in the N region from passing over to the P region. For a current to be able to flow through this P-N junction, electrical pressure is required, otherwise known as voltage. The voltage is required for the electrons to overcome the electric force of the field. Quantity of the potential difference of the depletion region between the P region and N region will give us a value for the amount of voltage needed for a current to flow across the P-N junction. This value is known as barrier potential. Practical examples where P-N junctions are used is the diode. Diode is commonly used to allow current to flow only in one direction. For example, it can be used in circuits to convert AC to DC with a capacitor, of course. A diode can be forward biased and reverse biased. To forward bias a diode, external DC voltage is applied and it allows current through the P-N junction. Most silicon diodes have a potential barrier of 0.7 volts. As the forward bias voltage increases, the depletion region reduces in width. When the DC voltage reaches 0.7 volts and keep increasing, the depletion region is closed and the current is allowed to flow across the P-N junction. In reverse bias, DC voltage is applied through the diode in the opposite direction. At first, this causes the depletion region to widen and no current can flow. Once the reverse voltage is increased to a high enough value, the reverse current flow will substantially increase. This voltage value is known as breakdown voltage. Also, the resulting heat by the unlimited current will permanently damage the diode. The breakdown voltage is specific to each diode make. This is how current flows through a P-N junction.